Let's read the question. If in a mixed oxide of elements A and B, the oxide ions are arranged in CCP lattice and cations A 2 positive occupy 12.5% of tetrahedral voids and cation B 3 positive occupy 50% of octahedral voids. The formula of the oxide is. Student, first of all, in this question we are given that oxide ions are arranged in CCP lattice. That means the number of oxide ions is equals to n. Also, we know that the number of tetrahedral voids is double of the number of atoms making the lattice, and the number of octahedral voids is equal to the number of atoms making the CCP lattice. So, number of B 3 positive ion is equals to, since these occupy 50% of the octahedral voids, that means 50 upon 100 multiplied by n, since I have already discussed that octahedral voids is same as the number of atoms making the lattice. So at the end, number of A2 positive ions is equals to 12.5% of tetrahedral voids. That means 12.5 upon 100 multiplied by 2n. As I've already discussed that the number of tetrahedral voids is double of the number of atoms making the lattice. That means the formula of the compound would become A. Let's solve this here only. N by 2, n by 4. So A will be n upon 4, B will be n by 2, and O will be n. Therefore, the final formula will become A B2O4. Or we can say that the correct answer for this question is option number 2. Moving to next question, students, which is question number 67. Let's read the question. Due to presence of F centers, LiCl crystal appears dash in the atmosphere of lithium. Student, this is a very easy question, as we all know that F centers, or because of F centers, the color of the crystal changes. And here, because of the presence of F centers, the color of LiCl, that is lithium chloride crystal, appears pink in the atmosphere of lithium. So the correct answer is option number 1. Moving to next question, students, which is question number 68. Let's read the question. In 0.1 molal aqueous solution of urea, the mole fraction of urea is. Student, for this question, we are given with molality of a solution, which is 0.1 molal. And for that, we need to know that 0.1 molal means that 0.1 mole of solute, here solute is urea, is present in 1000 gram, that is 1 kilogram of solvent. And since this is aqueous solution, that means the solvent is water. And now we have to calculate mole fraction. We have to calculate mole fraction of urea, and the formula will be number of moles of urea upon total number of moles, that is number of moles of urea plus number of moles of water. We are given with number of moles of urea, so we'll calculate number of moles of water, which is equals to mass upon molar mass, ultimately equals to 55.55. So let's put the value here. 0.1 upon 0.1 plus 55.55, which is equals to 0.1 upon 55.65, ultimately equals to 1 upon 556.5. That means the correct answer for this question is option number 3. Moving to next question, students, which is 69. Let's read the question, students. Which of the following change will decrease the vapor pressure of 0.1 molal aqueous solution of AgNO3? Students, as we all know that more the concentration of solute in the aqueous solution, lesser will be its vapor pressure. So let's find out in which case the concentration of the solution will increase, or the concentration of solute in the concentration will increase. As a result, the vapor pressure will decrease. So first is addition of water. Student, by dilution, the concentration of solute in the solution decreases. As a result, the vapor pressure will increase. Moving to next, addition of 0.2 molar AgNO3. Students, in this case, the concentration of the solute will definitely increase. As a result, the vapor pressure will decrease. But let's see the remaining options also. Addition of 0.1 molar AgNO3. Student, here the concentration of the solute will remain same. As a result, there will no change in the vapor pressure. Moving to last, addition of 0.01 molar AgNO3. Students, in this case, or the concentration of the solution will decrease. As a result, the vapor pressure will further increase. That means the correct answer for this question is option number 2. Moving to next question, students, which is question number 70. Let's read the question. Which one of the following is incorrect for non-ideal solution? Let's see the options. Pressure of solution observed is not equals to pressure of solution calculated. Student, this is the correct option for a non-ideal solution. Moving to next. Enthalpy of solution is not equals to 0. Student, this is also correct, as enthalpy of solution is 0 when the solution is ideal. It is either less than 0 or greater than 0 for non-ideal solution. Moving to next, delta T of solution less than 0. Student, this is also correct, as for ideal as well as non-ideal solution, the value of delta G is negative, that is less than 0. Moving to last, delta S of solution less than 0. Student, this is an incorrect option, as for ideal as well as non-ideal solution, the change in entropy will increase. As a result, we can say that the delta S for solution is greater than 0 for ideal as well as for non-ideal solution. That means the correct option for this question is option number 4. So I'm writing answer is option number 4. Moving to next question, students.